Welcome to Get Your FRQ On. This question is from 2001. It is question 5, and it is not calculator active. In the question stem, we are given a function f of x, which is a cubic function, 4x cubed, and then the rest of the coefficients are actually given as parameters. So we have 4x cubed plus ax squared plus bx plus k. And in the part A of this question, we are asked to determine the values of a and b if we know that x equals 1 is a local minimum and x equals -2 is an inflection point. So given the fact that x equals -1 is a local minimum and x equals -2 is a inflection point, we can actually differentiate the function f of x using the power rule to get equations with a and b in them. For example, the first derivative of f of x would be 12x squared plus 2ax plus b. And if I want this to indicate a local minimum at x equals 1, I would need to substitute -1 in for the x values so that I only have a and b left. If I do that, I get 12 minus 2a plus b. The second derivative we can also find. That's going to be 24x plus 2a. And since we need -2 to be an inflection point, we need to evaluate the second derivative at -2, which would get us -48 plus 2a. Now, because -2 is an inflection point, and f is a polynomial function, we should have an instance here where the second derivative is exactly equal to 0 at -2. So if we set up the equation, -48 plus 2a equals 0, that's a pretty easy equation to solve. We get a equals 24. However, that gets us a. Now we have to go back and use the fact that a is 24 in our expression for f prime of -1, because that needs to be a local minimum, so there's certain things that have to be true about that. Notice that f double prime of -1 is positive 24, which is greater than 0, which means that the function is concave up at -1, which means it will have a minimum in that interval. So if we can find a value of b where f prime is 0, it would be a local minimum at x equals -1. All right, so what value would that be? Well, if I know a is 24, I get 12 minus 48 plus b is equal to 0. And if we solve that for b, we get b equals 36. In part B of this question, we are given that the definite integral from 0 to 1 of f of x dx is equal to 32 and asked to use that to find the value of k. All right, so based on part A of this question, we've determined that a and b are 24 and 36 respectively. So now we have this function 4x cubed plus 24x squared plus 36x plus k. Well, in order to do the definite integral, we need an antiderivative of f, which in this case we can find by using the power rule for antiderivatives. That's going to be x to the 4th plus 8x cubed plus 18x squared plus kx plus c. That would be our antiderivative. And then we can go ahead and use the fundamental theorem of calculus. The definite integral from 0 to 1 of this function f of x equals 32 implies that big F of 1 minus big F of 0 is 32. And then we just evaluate what those would be. Big F of 1 would be 1 plus 8 plus 18 plus k. And then big F of 0 would just be 0. So we have, in the long run, 27 plus k is equal to 32, which implies that k is equal to 5. Thank you for watching. If you like my content and you want to see more solutions to AP Calculus free response questions, make sure you like and subscribe to my channel. It's going to help me out a lot. It's going to put my videos in front of a lot more people and share the calculus amazement with everybody out there on YouTube. If you like calculus as much as I do, it wouldn't hurt if more people learned it. Have a good day.